Assalamu alaikum. I am Muhammad Mahfuzur Rahman, ID 203353137. Now I am talking about code vulnerability and compromised software quality. Before we start our topic, let's think. In today's world, operating system and application are connected over the internet, are regularly updated. These updated for most time are not done to add more feature but to bug fix. This makes the system stronger against newly deployed virus and malware. Unfortunately, most software does not have this type of link and hence leaving them vulnerable to intruders. Two way you can make sure that your software isn't compromised is either by accessing the software at every machine to change the code every time an attacker comes up, or by decreasing your code vulnerability in your development process. So, what is code vulnerability? The term code vulnerability is associated with your software security. It is a weakness or a flaw that can potentially lead to the compromise of the software security. It is a flaw in your code that creates a potential risk of compromising security. This flaw will allow hackers to take advantage of your code by attaching an endpoint to extract data, temper your software, or erase everything. While we may feel this happen is highly unlikable, data from Contrast Security says that around 76% of application contains at least one vulnerability and 34% contain more than 4 vulnerability. What is software security actually? Software security is an idea of practice implemented to protect software against malicious attack and other hackers' risks so that the software continues to function correctly under such potential risks. Safety is the most priority. And what is quality code? A quality code is a measure how a good specific code set is. A quality code is one that is clear, simple, well tested, bug free, refactored, documented, and performant. But the primary measure of high quality code is compliance with the specification depend on the needs of the company. Code quality is not a new parameter for the code. In fact, it has been taught since 1970. Here are some characteristics of define a quality code. Extendability, maintainability, clarity, refactor, documented, well-tested, enhanced in efficiency, and a lot more. Ultimately, writing quality code is ongoing process that evolves collaboration, continuing learning, and a commitment of improving code over time. Main deployment teams use code reviews, static code analytic tool, and other practice to maintain and enhance the quality of their code base. What is readability? Code should be easy to read and understand. This involves using meaningful variable and function name, proper indentation, the consistent formatting. Readable code is essential for collaboration among the team members and for the maintenance of the code base over time. Maintainability. Quality code is maintainable, meaning that it can be easily modified or extended without introducing errors. This involves modular programming and where code is designed, organized into manageable and logically separated components. Documentation is also crucial for maintainability. Efficiency. Code efficiency is about achieving its the desired functionality with optimal use of system resource. This includes consideration for time complexity, space complexity, and algorithm efficiency. Scalability. Quality code can scale the accommodation, increasing demands and such of higher user load of large database. Security. High quality code incorporates security best practice to protect against vulnerabilities and malicious attacks. This include proper input validation, secure data storage, and protection against common sense. Threat like injection attack and cross-site scripting. Well tested. Well tested code refers to code that is undergone through testing to ensure the correctness, reliability, and robustness. Testing is the crucial aspect of the software development process, helping identify and fix bugs, ensuring that the code behaves as expected and providing confidence to the software overall quality. Documentation. Comprehensive and up-to-date documentation is a key aspect of quality code. Documentation includes comment within the code, readme files, and other document that helps developer understand how to use contribute to the code base. Adherence of coding standard. Following established coding standard for a style guide helps maintain to uniform code style across a project. or organization. Consistent coding standard contribute to readability and make the codebase more appropriate for developers. So there are some poor quality code is a security threat. The developers need to comply with the code metrics standard in their code because it is not only the deliver the functionalities to the software but also to ensure their code is bug free and the final product is not vulnerable to any security risk. Any compromise in a code quality may eventually lead towards security breach. So how we can mitigate this risk? Mitigate the risk is security threat associated with poor quality involves a combination of prevention measure, best practice and ongoing effort and identify and address vulnerabilities. Here are some strategies to help mitigate the risk. Prevention through detection. So, what is prevention through detection? Prevention through detection is a concept that emphasizes the importance of detecting issues early in the software development lifecycle to prevent them from escalation into more significant problem or security threat. By identifying and addressing issue at an early stage, development team can prevent the propagation of defect, vulnerabilities, or other problems through subsequent phase or development and deployment. Here are some key aspects of prevention through detection. Early bugs detection. Employ static code analysis tool and linear during the development process phase to identify the fixed coding issue, style violation, and potential bugs before code is committed. Continuous integration. Implemented CI practice where code change are automatically built, tested, and verified upon each integration into the main code base. CI pipeline should include automated testing and code analysis and other checks to catch issue earlier. Automated testing. Develop a comprehensive suite of automated tests, including unit tests, integration tests, and functional tests, to detect defect and ensure the correctness of the code. Incorporate security testing into the automated testing process to identify vulnerabilities early in the development cycle. Code review. Implementing regular code review is a collaborative process for identifying and addressing issues in the code. Code reviews can catch logic errors, security flaws, and other issues before the code is merged. Dynamic code analysis. Implementing dynamic code analysis or runtime testing to identify security vulnerabilities during the execution of the software. This can include penetration testing and vulnerability scanning. Static code analysis. Use static code analysis tools to analyze the source code for security vulnerabilities, coding standard violation, and other issues before the code is executed. We'll talk a lot more about dynamic and static code analysis. So, before talk about the dynamic and static code analysis, our first question is, what is code analysis? Code analysis, also known as static code analysis or source code analysis, is the process of examining source code for a software application without executing the program. The goal is to identify potential issue, vulnerabilities, and improvement in the code base. Code analysis can be performed manually by developers, but it is often automated using specialized tools to ensure through the consistent examination. When you talk about the code analysis, there is always a fight between the developer and tester. The relation between developer and tester is a crucial aspect of the software development process, and effective collaboration between these roles is essential for delivering high quality software. Here are some key aspects of for developer tester relationship. Static code analysis. So, static code analysis involves analyzing the source code without actually executing the program. It is performed during the development phase to identify issue and ensure compliance with coding standard. So, what is the purpose of static code analysis? Identifying syntax errors, coding standard violation, and other potential bugs. Detecting security vulnerabilities such as SQL injection, cross-site scripting, and buffer overflows. Analyzing code complexity and maintainability. Enforce coding standard and best practices. Here are some different tools that we can use in static code analyzing. Converity to prevent, and SonarQube, find bugs, GetAfix, HP45 is most popular in top quality country. Infer is another tool we can use in static code analysis. So these are some basic tools we can use for static code analysis. Now, security issue through code analysis. Top quality web application security flaws or security issue that can be found in a vulnerable code are first one is unvalidated input. So what is unvalidated input? Unvalidated input is a security issue that arises when a software application does not properly validate or sanitize input data received from user or external source before processing or using it. Failing to validate input can lead to various security vulnerabilities as attacker may exploit this weakness to perform malicious action or manipulate the application behavior. The primary goal of input validation is to ensure that the data received by the application meet the expected format, type, and constraints. Second, broken access control. Broken access control is a security issue that occurs when the application does not properly enforce restriction on what authenticated users are allowed to do. The vulnerability allows attacker to gain unauthorized access to certain functionality or data within the application. Broken access control can lead a range security risk, including unauthorized data access, privilege escalation, and other forms of unauthorized action. Third, broken authentication and session management. So, broken authentication and session management is a security issue that occurs when an application improperly implemented user authentication and session management, leading to vulnerabilities that can exploit by attackers. These vulnerabilities can result in unauthorized access to user account, session hijacking, and other security breaches. Proper authentication and session management are crucial important components for security web application. Fourth, one is buffer overflow. So, what is buffer overflow? A buffer overflow is a software vulnerability that occurs when a program writes more data, a block of memory or buffer that is allocated on hold. This overflow of data can lead to unintended consequences, including overwriting, adjusting memory, causing crashes, and potentially enabling the execution of arbitrary code. Buffer overflow are a common source of security vulnerabilities that can be exploited by attacker to compromise the integrity and security of a system. So, what are cause of buffer overflow? First one is input validation. Lack of proper input validation allow attacker to input more data than a buffer can handle. Unbounded copy operation. Functions like strcpy and C or C++ do not check the length of the input data, potentially leading to buffer overflow. And another one is stack overflow. So what is stack overflow? Writing excessive code to the stack, especially in the function with local variables, can overwrite return address and other critical information. Here we can see a stack overflow attack when there is empty space after the heap, but when we give additional input in the memory address, it's overflow the stack. So that's why it's called stack overflow. Security and the rest of the security issue are improper error handling, insecure data handling, insecure storage, denial of service or DDoS, and insecure configuration management. This all are the security issues which can handle by the software, not the network part. So what is the limitation of static code analysis? First one is large amount of false alarm produced by a static code analysis tools, which we showed previous slide. Time consuming while trigger manually, high dependency on programming language, perform based on fixed rule set, no intelligence applied. A typical static analyzer doesn't attempt or propose any fixed. There are some future scope of static code analysis. Difficulties or limitation often open the door of opportunities. No exception here as well. Improve the accuracy of the static analyzer by reducing false alarm. Integrate the analyzer with auto-built continuous integration system. Inclusion of AI-based intelligence analysis technique. Fourth one is autofix with high accuracy is the future of software quality through static code analyzer. And finally, the last one is focusing on software quality and security can create a great positive impact on IT industry and whole. This all the things we talked about the software vulnerability and compromising code quality. And there is a lot of scope where we talk only the static code analysis scope. In another day we will talk about the dynamic code analysis. Thank you.